Hello everyone, in this video I'm going to discuss the example for differentiation. A. By writing the tangent x is equals to sine x over cos x, shows that differentiate the tangent x with respect to x is equals to secant square x. Hence, find the first derivative where we have differentiate the tangent bracket with the angle cos 2x respect to x. So number 1, we have the tangent x is equals to sine x over cos x. If we want to differentiate the tangent x, where we have this part as a u and this part as a v. For the quotient rule, we have d uv with respect to x, where we have v u prime minus u v prime over v squared. So let us begin. Differentiate the tangent x with respect to x, or we can say sine x over cos. First, what we have to do is to substitute the v, where we have the cos x, multiply u prime, where we have to differentiate the sine, where we have the cos x, minus, where we have the u, sine x. If we differentiate the cos, where we will have negative sine x, over, we have the v squared, where we have cos x bracket square. Kindly expand the situation where we have cos square x plus with the sine square x over the cos square x. So as we all know, cos square x plus with the sine square x, by referring to the basic identity where we have 1 over cos square x. As we all know, 1 over cos is equals to secant x. Then we can say it, differentiate the tangent x with respect to x, where we will have secant square x, where we already shown the situation. Hence, find the first derivative, differentiate tangent with the angle cos 2x respect to x. So d dx for the situation, tangent bracket cos 2x. So if we differentiate the tangent, and we will have secant square bracket cos 2x. If we differentiate the cos, we will have the situation negative sine 2x. If we differentiate the 2x, and we will have 2. So rewrite the situation. Differentiate the tangent bracket cos 2x with respect to x, and we will have negative 2 sine 2x. Then multiply with secant square bracket cos 2x. Next, kindly refers to b. Given we have the situation sine bracket, we have the angle 2xy equals to x plus cos, we have the angle xy squared. Evaluate dy dx when y is equals to 0. So first what we have to do is to find out the value x. So if we substitute y equals to 0. So in here we will have sine bracket 2x multiplied with the 0 equals to x plus cos bracket, we have x bracket 0 squared. So sine 0, and we will have 0. Cos 0, we will have 1. So x is equals to negative 1. Next is to differentiate the situation. Focus on this part. Differentiate the sine bracket 2xy with respect to x. So differentiate the sine, we will have cos bracket 2xy. Next, focus on the angle. Making use of the product rule, where we have y, then multiply with the 2, because we differentiate the 2x. And then plus, highly focus on 2x. If we differentiate the y, and we will have the y prime. Continue. Differentiate the x with respect to x, and we will have 1. Next, differentiate the cos bracket xy squared. If we differentiate the cos, and we will have the negative sine bracket xy squared. Differentiate the angle, making use of the product rule, where we have y squared. Differentiate the x, and we will have 1. Plus, we have x. Differentiate the y squared, where we will have 2y, y prime. So, evaluate the dy dx. What we have to do is to substitute the value y equals to 0, x equals to negative 1. So, for this part, if we substitute 0, where we will have cos bracket 0. Continue. We have 2y. So 2 multiplied with the 0 plus we have 2x. Then y prime. Focus on the front part. Here we will have 1. Here we will have 0. Here we will have negative 2y prime. So conclusion, for the front part we have negative 2y prime. Next, we have equals to 1 minus, if we substitute 0, so here we will have sine bracket 0. Then if we substitute y squared as a 0, plus we have x negative 1, and then we have 2y, and then we have the y prime. So for this part, here we will have 0, so where we have equals to 1. So the dy dx is equals to negative 1 over 2.
If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.